We're going to expand our definition past what we've learned as the Arrhenius acids and bases. And we're going to expand it to what is known as Bronsted-Lowry acids and bases. And Bronsted-Lowry says that acids are H plus donors. So when they're added to water, water acts as a base, accepting the hydrogen from our acid and forming the hydronium ion. So this is fairly similar to the Arrhenius definition, where the acid has to have a hydrogen that can be donated. If we look at Bronsted-Lowry bases, this is where the definition changes a bit. So bases are H plus acceptors. So our water acts as an acid, donating a hydrogen. So in this case, ammonia, which would not be considered an Arrhenius base because there's no OH. The acid actually donates a hydrogen and forms ammonium, and then we actually do end up with hydroxide, but that hydroxide comes from the water, not directly from the ammonium. So that the water donates, acts as an acid, the NH3 accepts it, and that's what makes it a base, because it can accept that extra H plus. You may have noticed in the previous slide that the water acted both as an acid and as a base. This is what we call an amphoteric substance because it has a hydrogen that can be transferred. That makes it able to donate a hydrogen acting as an acid, or it has an extra lone pair that allows a hydrogen to be accepted. So water, when it's accepting hydrogen as a base, when it's donating hydrogen, it is an acid. Let's look at an example reaction. So if we look at our ammonia, which is our base, and the water, which is an acid, the acid is going to donate a hydrogen to the ammonia, and that will leave it as OH minus. Now on the product side, that extra hydrogen that was donated to our ammonia means that it can also be removed, making this an acid. The OH minus can accept a hydrogen, which means that this is a base. Because they're on the product side, we call them conjugate acids and conjugate bases. These conjugates differ from the original substance by one hydrogen. So our base that accepts a proton becomes the conjugate acid. The acid that donates the proton becomes the conjugate base. And again, the only difference is one hydrogen between our conjugate acid and our conjugate base pairs. And we do refer to these as pairs. So that's why the lines are drawn linking the two substances. Pause the video and see if you can determine the conjugate acid for the substance on the left and the base, conjugate base, for the substance on the right. Pause the video to determine your answers. Let's look at water. So water, if we're going to write the conjugate acid, that means that it has to gain a proton. So water would become NH3 plus. The hydrogen, the extra hydrogen, has a positive charge, so we increase the charge by 1, and we increase the number of hydrogens by 1. If we're going to look at water as a conjugate base, the conjugate base, we have to remove a hydrogen, which decreases the amount of hydrogens by 1, and it also decreases the charge by 1, making it OH minus. NH3, if it's the conjugate acid that we're writing, we're going to increase the number of hydrogen by 1 and also increase the charge by 1. If it is the conjugate base, we're going to remove a hydrogen. Now this is not nearly as common for NH3 to become NH2 minus, but this would be the conjugate base. CO3 2 minus, so this is carbonate. Carbonate can gain a hydrogen, and we would increase the charge by 1, so this is hydrogen carbonate, or also sometimes known as bicarbonate. If we look on the right side, we have to remove a hydrogen, but that is not possible because there is no hydrogen, so it cannot be an acid. Okay. Cannot have a conjugate base. All right. If we're going to write the conjugate acid for H2PO4 minus, again, we're going to add a hydrogen, becomes phosphoric acid. We increase the number of hydrogen and increase the charge by 1. For writing the conjugate base, we're going to decrease the hydrogen and decrease the charge by 1. Let's look at identifying our conjugate acid-base pairs. Okay. Remember, we are only changing the substance by 1 hydrogen. So if we look at our pairs, the H2SO4, so sulfuric acid, and the water to hydronium are going to be our pairs. Now we have to decide which one is the acid and which one is the base. So remember, acids donate hydrogen. So in this case, the sulfuric acid is going to act as an acid. It donates 1 hydrogen, and when it loses that hydrogen, it becomes the conjugate base. The water is going to accept the hydrogen, so that makes this the base. The H3O plus has that extra hydrogen, making this the conjugate acid. Okay. All right, in our next example, again, we're looking at the substances that only differ by 1 hydrogen. So we're going to look at our hydrogen carbonate compared to carbonic acid, and water compared to OH minus. Now, our HCO3 minus has gained a hydrogen on the right side, so it's accepted it. So this is our base. That makes the carbonic acid our conjugate acid. The water has donated a hydrogen, so that makes this the acid. The OH minus would be our conjugate base because it has the ability of accepting a hydrogen. Here's one for you to practice with. Pause the video to identify each of the acid, the base, the conjugate acid, and the conjugate base in the following reaction. If we look at our pairs, the HSO4 and SO4 will be one pair. The hydrogen carbonate and the H2CO3 will be the other. So our HSO4 has given up a hydrogen. So this is our acid. That makes the sulfate our conjugate base. The HCO3 is going to be the base, and it is going to become H2CO3, which is carbonic acid. It's our conjugate acid. Let's take this idea one more step. Use these substances and react them with water, and each one of these is acting as a monoprotic acid. label the conjugate acid and base in the reaction. Pause the video to determine your answer. We want to react it with water, and we're told that it is acting as an acid. That means that the water is going to be our base. So if the water is the base, that means that on the product side, the water is going to become a conjugate acid. It's going to accept a hydrogen. The acid is going to donate a hydrogen, and so we decrease the substance by 1 hydrogen, and we decrease the charge by 1. So it becomes Br minus, our conjugate base. If we look at our second substance, the HSO4 minus, so if that is our acid, that means our water is going to be the base. The HSO4 is going to donate a hydrogen, so we decrease it by 1 hydrogen, decrease the charge by 1, becomes SO4, 2 minus, so sulfate. So this is our acid. Makes a conjugate base. The water is our base. It becomes the conjugate acid by gaining a hydrogen and a +1 charge to be our conjugate acid.